Good afternoon once again, class. Today we're going to continue our discussion on multiple linear regression. By way of quick review, we were working on this data set wage.csv, and I hope by now you understand the importance of creating an R project where all your data, whether it's an RMD file or images or a data file, is stored in that project. This also will save the trouble of, for example, if accidentally there was a power outage and your computer gets turned off, uh, there will be automatically saved a working file of what you were doing before the let's say the power went off. So for today, let's just quickly review what we have done so far. Let me load the just a tidyverse package. So let me just uh, do this library tidyverse. We're just going to use this for today. Okay. And then we said that part of tidyverse is the readr package. So we can use this read_csv. And the advantage here is that if the data is loaded in your project, then you will not need to put the file location because R will automatically understand that it's here in the project. So let me run this. And so I now have the wage data set here. There are 8 variables here. We have done this before, so I won't repeat the process. And I won't do some descriptive statistics. We have done this before. Let me just go through quickly the correlation. Okay, sometimes you might wish. Let me view this. We said that when we do multiple linear regression, we want the variable of interest, the dependent variable, to be correlated with our independent variables, highly correlated with our independent variables. And the correlation, of course, is expressed through numeric variables and not necessarily through character variables. So let's create an object. Let's call it wage 1, 1, 2, 3, 4, 5, 6. Let's just remove race, gender, and civil status. So this is columns 4, 5, 6. And let's see the correlation. Okay, so let me go here. All right. I think last time, okay, is it here? Yes, I think it's here. Let me just copy this to save on time. We can use the psych package. Okay. Okay, where is that? Let's use the psych package. I hope I can find it. Is it here? I don't think I saved it. No, it's not the describe. We want to, okay, let me open this. All right, this is what we did this morning. So we will try to, this one. I'm using the peers panel, and we said that even if we don't load the psych package, we can make use of the functionality by using the namespace. All right, so let me just copy this. Okay, here. Okay. Now, before we do this, let's create this object wage1, which does not include the character variables. So let me create this object wage1. Okay, and this object comes from wage. And then let's subset it to include all the rows but we're going to remove the fourth to sixth column. Okay, so take a look at this. It's subsetting. The first item here is the rows, and we're not putting anything here, which means all the rows. And then for columns, we remove 4 to 6. Let's just check this. 1, 2, 3, and then 4, 5, 6. So we remove the fourth to the sixth column. And we create this object wage1 to preserve the original wage data. All right, and then we use, we can also use the GG ally package. And there's this, the pairs GG ally. Where's the pairs? Oh, sorry. Pairs ba? I don't usually memorize. Let me see. GG pairs, wala pa lang ano, sorry. Walang, okay, GG pairs, there. Okay. All right, so if I'm moving too fast, class, it's because this is just a bit of a review. Okay, we're creating this object wage1, and if you check wage1, if you run this, you now have a data frame that consists only of the numerical variables. We deleted the character variables so that when we do the pairs, let's run this. From the site package, we do the pairs.panels. It will give us a pairwise comparison of the of the numerical variables. You can find here the distribution, okay, of education with experience. This is the scatter plot. Okay, this is the individual distribution of the different variables. All right, then we have here the measure of the correlation. This is the correlation between education and experience. It's negative 0.3. The only disadvantage here is that it does not reflect the significance of the correlation. Okay, but if we use this one from the GG ally package, and then we use the GG pairs function, let's run this. All right, attendance mamaya na lang ha. So we can see here that same thing. You have the scatter plot of the bivariate education and experience, etc. Then you have this individual distribution of the variable. And then you have the correlation metric with the significance. So we can find here that education and education and experience, the correlation is negative 0.3, and it's statistically significant. Experience and tenure are also correlated at practically 0.5, statistically significant also. We're interested more really on the hourly wage, and we can see here that it's positively correlated with education, and the correlation is significant also with experience. It's not the correlation with number of dependents. It's not statistically significant. It's very small, negative 0.05. So if ever we're going to use predictors for hourly wage, these three will be good candidates, but not number of dependents. But also corollarily, we said that we don't want the variables, the predictors, to be having a high correlation with each other. Okay, for example, itong experience and tenure, okay, number of years of experience and tenure, they seem to be highly correlated, 0.5. The correlation is statistically significant, and when we check the condition of multicollinearity, that might be a problem. So we will reserve the checking of the diagnostics of the model in due time. Okay. In the meantime, let's continue with this. And what we have done so far was to create this object called mod1, where we regress hourly wage on education. We said that this is just a simple linear regression. We can combine the model itself and the summary. Okay, so this one, summary of model 1, where we regressed hourly wage on education from the data wage. All right. When we run this, it will generate the main output. Okay, so very quickly, there's this call to the formula first, and then the residuals, distribution of the residuals, which we're going to need when we do diagnostics. And then this one, education, intercept. These are your parameters. These are your individual tests. Okay, individual t-test, t-stat. And here you're told that education is statistically significant, while intercept is not statistically significant. Last time, we also learned how to interpret this. For education, which is 0.54, it means that for every $1, or for every 1 year increase in education, I say 1 year because education is a parameter that's whose dimension is in years. You have to follow the dimension of the variable. For every 1 year increase in education, there's a corresponding $0.54 increase in hourly wage. It's an increase because it's positive, and it's in dollars because hourly wage is in dollars, $0.54, and it's statistically significant. And then we said that the interpretation should be with ceteris paribus, which means if there are other variables that was used to predict or explain your dependent variable, they should remain constant. So ceteris paribus means all other things being constant. Now for the intercept, it's negative 0.9, and its p-value is 0.187, which is greater than 0.05, which means that this is not significant. The null hypothesis here is beta null, beta 0 is equal to 0. So we fail to reject the null hypothesis that beta 0 is equal to 0. So there's this strong statistical reason to believe that your intercept is equal to 0. However, we said that intercept, even if it's not statistically significant, still is included as a way of practice, by way of practice in the model. So our model is our hourly wage predicted, the hat hourly wage is equal to negative 0.90485 plus 0.54136 times education. And since we're putting hourly wage as a hat, we need not to put the epsilon. Okay, so I hope you remember that, class. When I write here hourly wage hat, okay, this means this is the predicted value. So since it's predicted, then this is an exact value. You don't need to put, okay, let me just write the 90, okay, that's 2 decimal places, plus 0.54 times education. Okay, so I'm not putting any plus epsilon here plus an error term because this is hourly wage. However, when I remove this, if it's only hourly wage sub I, then this is your predicted value, and your predicted value will not be equal usually to your actual value. So we have to put here a plus epsilon sub I. The difference between the actual value and then the predicted value is your error term. All right. Also, we looked at, let me clear the drawings. Okay, let me pause for a while. Any questions so far, class? Kindly chat, please, if everything is clear so far. Do you have any questions? Okay, good. How about the rest? Waiting for the others to give their feedback. Okay, thank you. I hope to get 100% feedback from you. Thank you. Thank you, class. Okay, so we also looked at this portion here. And by the way, what does the 3-star here mean? This means that the parameter, education parameter 0.54 is significant at 3 stars, this one, at 0.001. So the p-value is less than 0.001. Okay, and we said that if the p is low, the null must go. The null hypothesis here is that, let me write again. The null hypothesis here is H null is beta 1 is equal to 0. Our beta 1 referred to our education. Okay, beta 1 is equal to 0. So since the p-value, okay, is less than, in fact, it's less than 0.001. And it's not even less than 0.05. It's less than 0.001. Okay, so we reject the null hypothesis that the beta 1 is equal to 0. There's strong statistical reason to believe that your beta 1 is a value other than 0. And the average value is 0.54. Okay, and we interpreted that to mean that for every 1 year increase in education, there's a corresponding $0.54 increase in hourly wage, ceteris paribus. So this is the marginal effect, marginal effect of education, of a 1 unit increase in education on your hourly wage. Okay, and then we took a look at this 524 degrees of freedom, F-stat. Notice that F-stat has 2 degrees of freedom, degree of freedom 1 and degree of freedom 524. DF1 pertain to this degree of freedom 1. Degree of freedom 1 pertain to your intercept. Okay, we have 1 intercept. Okay, so that's 1 degree of freedom lost because you're computing for your intercept, then we lose a sort of a power. Okay, so that's 1 degree of freedom. The other degree of freedom is it's equal to your n minus k minus 1, where your k is your number of predictors. Okay, and 1 is to account for your degree of freedom 1, for your intercept. So our n here is how many observations do we have? 526 observations. Okay, minus k, k is 1. You only have 1 predictor, and 1 will be for your intercept. So there are 524 degrees of freedom. DF2, the second degree of freedom. Now we need this before DF1 and DF2 in order to take a look at the table, F statistic table. But nowadays, we don't do that anymore. So kasi in the F statistic table, you'll be able to find the p-value. So now statistical softwares already provide the p-values. So we base it here, our inference. And the null hypothesis here for this is what we call ANOVA, analysis of variance. Okay, or the overall goodness of fit test. That's another name. And the null hypothesis is that H null is equal to beta null is equal to beta 1 is equal to 0. So this is what we call overall goodness of fit test, combined test. Okay, and then since the p-value is significant at 0.001, we reject the null hypothesis, this null hypothesis. And we say that at least one of these parameters, beta null or beta 1, is a value not equal to 0. Okay, so we also looked at this one, the multiple R squared. And what do we derive from this one? The multiple R squared tells us the proportion of the variability of your dependent variable that can be explained by our independent variables, by our model. So the higher the R squared, the better. Okay, because our model is able to explain a bigger chunk of the variation of your dependent variable. However, class, you notice that there are 2 R squareds here, which we're going to look into in a while. There's this multiple R squared and there's this adjusted R squared. Now, necessarily, if you keep on adding to your predictors, say you have 100 predictors, that's quite a lot. Your R squared will always be greater if you keep on adding to your predictors. But that's not the objective of a multiple linear regression. In fact, we believe in what we call parsimony, a parsimonious model. If we're able to explain our variable of interest in the fewest variable possible, then that's better. Okay, because in actual life, in research, uh, it will be very expensive to have, imagine 100 variables. You have to survey tons of people, and then you have a big questionnaire asking for 100 items, maybe, etc. Compare this with just having 5. Okay, so which do you think will be more expensive, this one or this one? Of course, you will not wait for your answer. This is the answer. I mean, this is the answer. Okay, so we would want our model to be parsimonious. True, the R squared for this one, R squared, will be higher if we have 100 variables compared to 5 variables. Definitely. However, there's this measure now, not now, but this has been a measure ever since, adjusted R squared, where we penalize the model for having many regressors, many explanatory variables. So what's relevant for us in a multiple linear regression is the adjusted R squared, okay, rather than the multiple R squared. Okay, we don't want really to have a very, very high I squared where you have several and maybe unnecessary independent variables. The more compact, the lesser the number of variables are in explaining your dependent variable, the better it is, the better the model is. That's why adjusted R squared is a better metric compared to multiple R squared. Okay, so we're going to compute for this later on. So any questions, class? Are we clear so far? Kindly chat, please, if our discussion on both the individual test and the combined test or overall goodness of fit test. I hope they're clear. Good. Okay, thank you. Okay, good. All right, so let me clear my drawings and let's go now to a multiple linear regression model. Right, so just this, remember we discussed this. The hourly wage, the wide hat here, is equal to your intercept plus the slope of your independent variable. And there's no plus epsilon sub I because this is the predicted value. But if you're going to remove this, then there should be a plus epsilon v. All right. By the way, I created a video explaining how to make use of matrix algebra in solving multiple linear regression. So I'll just post it later for your perusal. Please watch that because we're not going to discuss that. But I expect you to know that. Okay. Here there's a discussion of diagnostics. You don't just stop at generating your model. You have to test whether the assumptions of classical linear regression model have been followed or have been satisfied. Otherwise, we need to do something about the model. But we will do that when we go to the final model. For now, let's create another model. Okay. By the way, here, yeah, okay, we did that already. So now let's Control Alt I. Let's now do another model. Let's call it model 2, Alt minus. Okay, and then we're doing the LM model. Hourly wage, shift tilde, regressed on. Okay, let me see. Okay, let me get the names of the wage dataset. Okay, dito ko lalagay na lang ha. So, names, wage. I just want to copy this. Okay. Okay. Sorry. By the way, before we proceed, take note that when we take a look at the structure of our data set, so you have here numeric, and then here you have character. All right. Now let's discuss this first. Can you use a character variable as to be a regressor? Yes, you can, provided they are what we call classifiers or factors. We discussed this last time. We said that a character can be used as a factor. But of course, not all character variables can be used as factors. You have to check whether that variable can be considered as a factor. For example, race. Diba? Pwedeng classifier to, white at non-white. Si gender, the same. It's female and male, so we can use this as a classifier. Civil status, single, married, we can also use this as factors. There are some character variables where you may, which makes it absurd to use it as factors. For example, you have this field address. And unless you would want to classify the exact address, okay, as classifiers, then you can make it a factor. Otherwise, okay, otherwise you don't use it as a factor. So the question is, how do we convert a character variable into a factor? So let's do that first. Okay, so how do we do that? Let's now specify that under wage dollar. So what are the variables here? Raise. Okay, what we're telling R is that wage dollar raise, okay, which is the variable raise from the wage object, we make it a factor as that factor. So this is one way to go about it. And let's just copy this, Control C, Control V. Okay, and I'm going to copy this, Control C, and also Control V, Control D, and just change this, the race, dollar, I'll make it gender. This also gender. Oops. What happened? Gender. And also the civil status, dollar. Easy for us to do that so that it will generate the variables under wage. Also this one, I remove the dollar first, put the dollar there, and then it will give us the drop down list of the variables under wage. All right. So, and then let's run also structure of wage. Maybe I'll separate this 1, 2, 3. Okay. And I'll run this full code chunk. So what is this code? The wage raise, we're converting it to a factor, also gender, also civil status. Okay, bakit ayaw mag-run? Ay, tama naman. Again. Yeah, okay. All right. So what do we now have? We can now see that when we check the structure of wage, factor na siya. Factor with two levels, factor with two levels, uh, two levels. All right. Now, when we view, i-view natin si wage. May nagbago ba? May nagbago ba kay wage? Wala, pareho lang, di ba? Si race, white pa rin, si gender, civil status. Gender, civil status, pareho pa rin. But something happened here as far as the structure is concerned. Now, what happens is that itong mga ano na to, these factors are now converted into what we call dummy variables. So si race, si gender, si civil status, they're now converted into what we call dummy variables. Dummy variables. Okay, how many dummy variables? So the formula here is k minus 1. That's the number of dummy variables where k referred to the number of levels of your factor. Okay, in the case of race, what are the levels here? So kay race, dalawa, no? Non-white at saka white. So we have to know the levels of the factor variable. So what R does is that it alphabetizes it. Tapos kung ano yung nauuna, in this case, non-white nauuna kasi letter N to. So this will give it a value of 0. And si white will be given a value of 1. All right? So how many dummy variables will be created? It's the number of levels minus 1. So for race, there are 2 levels. 2 minus 1, therefore, there will be only 1 dummy variable. Why only 1 dummy variable? Because 1 dummy variable is able to account for all the values of race. Okay, let me explain. Kasi di ba si race, dalawang level siya. So ang gagawin dito ni R, yung at the back of this, ito gagawin niyang, sino yung gagawin niyang 0? Yung alphabetically mauuna, si non-white. So this will be 1, 1, 1. Lahat ng white gagawin niyang 1. Si non-white gagawin niyang 0. So pag may non-white yan, 0. So with just this one dummy variable, were we able to capture all the levels of race? Yes. Kasi si white, 1. Pag nakita niyang 0 dito kay race, ibig sabihin yun, non-white siya. Okay? Ganun din kay gender. So gender has 2 levels according to the structure. No? Si female at saka si male. So what R will do is that it will convert this into a dummy variable na naman. Ilang dummy variable? Isa na naman. Bakit isa? Kasi ang tanong, ilang levels si gender? Dalawa, female at saka male. Therefore, ang gagawin ni R, ito, si female, gagawin niyang, kasi alphabetically nauuning female, 0. No? Alphabetical class siya, 0 to. Si male, 1. Therefore, itong gender na to, ito magiging 0, 0, 1, 1, 1, 1. So lahat ng female, 0. Okay. Lahat ng male, 1. Therefore, so if we take a look at this one, this row for example. Okay. So ito, 1 siya. So alam natin, white yan. Kasi sa race, ang 1, white. Dito, 1 siya. Ang male, 1. Kaya alam natin na white at male ito. So we're able to capture the attribute of a particular observation with dummy variables, replacing your characters with numbers 0 or 1. Okay, ganun din dito si civil status. Since married comes first compared to single, single will take the value of 1, married will take the value of 0. 1, 0, 0, 0, etc. Of course, you can change that. You can assign si single yung 0, si married yung 1. But we'll not go there now. No? Now, yung 0 plus, yung 0 na ginawang yung 0, yung alphabetically na una na ginawang 0, it's called benchmark. So meron tayong benchmark, no? Yung nauuna alphabetically. So dito kay race, non-white at saka si white, ang benchmark natin si non-white. Dito kay gender, ang benchmark natin si female. Dito kay civil status, ang benchmark natin si married. Now that's very important because later on when we interpret the results, dapat alam natin, no? Kung ano yung ibig sabihin, no? Okay. All right. So let me give an example. Suppose you have a factor, year level, and let's say you have 4 levels. Sabihin natin, kunyari, frosh, sophomore, SO, junior, at saka senior. Okay, ang tanong, how many dummy variables will be created out of this? Answer please, pakichat. How many dummy variables will be created out of this year level data? Krisha, thank you. How about the others, class? 3, Angel, thank you. Okay, Emil, okay. Thank you. I hope the others got it. Yes, you're correct. 3. No? Tatlong dummy variables. And how will that look like? How will that dummy variable look like? Clear ko na muna para... Okay. So dito, sabihin natin meron tayong year level dito. Year level. Sabihin natin dito, frosh, kunyari, senior, junior, sophomore. Example lang to, sophomore, frosh, senior, sophomore, etc. Okay. Now, sabi natin, class, tatlong dummy variables ang kailangan dito. No? How did we get that? The number of levels is k, which is equal to 4 minus 1. So, three dummy variables. So, how will those dummy variables look like? So, tingnan muna natin ang gagawin ni R. The alphabetical, the letter that will that's first alphabetically is F. Therefore, F will be your benchmark. So, benchmark si F. So, ang mangyayari, tatlong dummy variables, meron tayong sophomore, meron tayong junior, meron tayong senior. So, tatlo lang, ha? Tatlo lang. So, how will this look like? Frosh to, frosh. So, 0, 0, 0 yan. Kasi sa frosh, hindi sophomore, hindi junior, hindi senior. Itong senior, 0, 0, 1. Kung ano yung attribute niya, dun siya malalagay. Si junior, 0, 1, 0. Sophomore, 1, 0, 0. Notice na iisa lang pwede niyang paglagyan, no? Kasi hindi naman siya pwede maging sophomore and junior at the same time. Frosh, 0, 0, 0. So dito, class, kahit na wala kang frosh dito, captured pa rin yung data na yun kasi 0, 0, 0, frosh yun. Okay? You might say, bakit hindi na lang maglagay ng F dito? Para kung F, di magiging 0, 0, 0, 1 yan. Okay? So, lahat ng hindi F, 0 din dito. Lahat ng F. Okay. Now, the reason why we do not include another dummy variable to represent yung benchmark natin is because we will fall into what we call a dummy variable trap. Okay? And what will lead to a dummy variable trap? We will have what we call perfect multicollinearity. Okay, remember, one of the requirements for a linear regression model is that dapat walang multicollinearity among the predictors. This is a perfect multicollinearity. Okay, makikita natin next time yan, no? When we plot, when we do a multiple regression. Tapos maglalagay tayo ng perfectly collinear na variables. All right. So is this clear, class? So kung you have to know how many levels that variable is, that factor, and then minus 1. Sa R, kung ano yung alphabetically mauuna, siya yung magiging benchmark. So magiging walang variable na frosh dito kasi it's accounted for naman, no? All right. Kindly chat please if that's clear. Clear ba siya, class? Yung concept ng dummy variables, okay? All right. Although hindi natin nakikita dito yung dummy variables, pero that's what R does. And so since yung race natin, gender natin, at saka civil status natin, numbers na siya, 1, 0, 1, 0, 0, 0, 1, etc. Then they can now be computed. They can now be used as predictors, no? Sa model natin. Okay, questions? Okay, how about the others, please? Pause muna ako kung clear so far, class, yung discussion natin. Okay, thank you. All right. Okay, salamat. Okay, back to our model. Right. Yung first model natin, class, is just a simple linear regression kasi ang ginamit lang natin si education lang, no? Now, ang gagawin natin, we're going to use all of these variables in coming up with a model. Okay, let me see. Kaso doon mag-run to, no? Okay. Ito na lang, Control-Alt-I, and then names, gagayahin ko tong names na to. Wage. Yes, so dito siya. And then Control-Alt-I. And then we're now going to create our summary mod 2. We'll call it mod 2. And it's your linear model ng hourly wage. Okay. Regressed tilde. Regressed on. Okay, copy natin tong Control C, Control V. So on education. And then experience. Palit natin ng mga plus to. Okay. And then kailangan natin sabihin yung data is equal to wage 1, 2. Kulang pa. Let me check. Mod 2. Summary 1, 2, 3. LM to. Dali Kasi nalito ko dun sa, ito na muna. LM na muna. Ito. Okay. Ito pala. Yan. So this is our LM. 1. Ito yung LM natin, ano? Okay, and then we're going to assign the name mod 2 to it. Okay. And then summary natin. Yan. Okay. Shortcut, sinummarize kagad natin. So, si model 2 will consist of the objects that come with the linear regression output. Okay. So LM, ngayon ko lang para mas clear yung ano natin. Let me just fix so that you can easily see. Kasi masyadong magkaka-dikit sila, no? Para may content space lang. Okay, so this is our model. LM, hourly wage regress on education, experience, tenure, race, gender, civil status, number of dependents. So there are 7 variables. Actually, the shortcut for this one is, copy natin ito. Control C. If you're using all the variables on model nyo, you can just do this. Okay? So it will give us the same answer. This one means that we're regressing hourly wage on all the variables. Okay? Data is equal to age. All right, so let's run this. Let's take a look at what the output is. Okay, kindly chat please if you were able to get the model. Waiting for the others, class. Feedback, please. I only got one. Waiting for the others. I hope you're following class. Only a few. 3 or 4 pa lang nakasunod. Let's wait for the others to generate this output. Ito yung equation, no? This is the shortcut. No? Tilde and then dot. Dot here means all the variables, except of course hourly wage. About the others, please. Five pa lang, nakahabol. Okay, let's give our classmates a few more seconds. Okay, thank you. I wish there were more responses from you. Okay, so let's interpret this. Okay, so first we have the individual tests. So there are 8 hypotheses here. The first hypothesis is that beta null is equal to 0, B1 is equal to 0, everything here, B1 is equal to 0. Okay, for the intercept, we notice that the intercept is statistically significant at 0.001. Diba? 3 stars. No? Significant siya at 0.001. Whereas before, diba, hindi siya significant. Ngayon, significant siya. About education, still significant at and we were expecting this kasi si education siya yung highest na correlation with hourly wage. 0.57 and practically the same pa rin dun sa kanina, no? How much was the marginal effect? Anyway, okay. So 0.57, how do we interpret this? And this is also statistically significant, no? At 0.001. And we say here that for every 1 year increase in education, there's a corresponding $0.57 increase in hourly wage. Ceteris paribus. Okay, we have to include ceteris paribus, remember. So what's the meaning of ceteris paribus? All things being the same, all things being equal, which means that you look only at the marginal effect of education. 1 year increase in education means 0.57 increase in hourly wage without us increasing experience, tenure, etc. No? Kasi kung mag-increase yung si tenure, may marginal effect din yan, for example. Diba? So we're looking at it one variable at a time, 0.57. Okay, how about experience? Experience is, okay, since we set our alpha, diba, ang alpha natin is what's our alpha class? Level of significance. And the default usual ang ginagamit 0.05. Okay? And then, ang beta naman, beta is your level of confidence, which is 1 minus alpha. Okay, so if alpha is 5%, then our beta is 95%. Okay, so another way to look at this is we're 95% confident that the value of your education is not zero. Ito naman, it's what one dot, di ba? Ito. Kasi yung one dot, ito. So it's significant at 10%. Okay, but since we set our level of significance at 0.05, then we are rejecting this, no? That this is, we're rejecting the null hypothesis that beta 2 is equal to 0. Okay, how about tenure? What's the meaning of tenure? For every 1 year increase in tenure, there's a corresponding $0.138 increase in hourly wage, ceteris paribus. Okay, now number of dependents, it's not significant. And we were expecting this kasi, di ba? In terms of correlation, si hourly wage at saka si number of dependents, hindi sila correlated. Di ba? I hope you recall that. All right, now let's take a look at this. Ano ibig sabihin ito? Ito yung importante sa atin ngayon. This is hopefully a very important lesson for us to learn this afternoon. Itong race white. Okay, remember, si race white, factor to, di ba? Yung race variable. And then ang ginawa natin dito si non-white, we benchmark it. We made it 0. So ang lumabas lang dito yung number 1, si white. 0.11, approximately 0.11. Okay, although it's not significant, no? Okay, so punta lang tayo sa male dito. Male is significant. Yan. Okay, 3 stars, no? Significant at 0.001. Okay, si gender male, ang parameter niya 1.76. So what does 1.76 mean? So 1.76 means that male employees on the average earn $1.76 hourly wage more than their female counterparts, ceteris paribus. Ulitin ko male employees on the average receive $1.76 more. Bakit more? Kasi positive yan. More than whom? More than their female counterparts. Okay? Ceteris paribus. Okay, so when you interpret those factors, it's always interpreted in the light of the what? The benchmark variable. Okay, si race white, hindi significant no? Pero let's assume it's significant. So 0.11. 0.11 yung yung ano niya, yung slope, no? Ito. So let's assume that this is significant. How do we now interpret this? On the average, while white employees receive 11 centavos more in hourly wage compared to their non-white counterparts, ceteris paribus. Okay? Although, hindi siya significant. No? So, pag hindi significant, hindi natin may interpret yan. Kasi there's a chance that the value is 0. Okay. Yung single din, ganun din dito, no? Yung civil status. Negative 0.46. But for purposes of discussion, let's assume that this is significant. So what does this tell us? On the average, single employees receive $0.46 dollars less siya, no? Kasi negative. Less than their married counterparts, ceteris paribus. So mas malaki yung on the average na hourly wage ng mga married compared to yung mga single. No? Call it discrimination or what? We don't know. No? We don't know. All right, number of dependents, we know how to explain that, but it's not statistically significant. 0.18. All right. Now, ano ibig sabihin itong intercept? Kasi we looked at education, experience, tenure, all of these variables, pati yung mga dummy variables. No? We always interpret this in light of the benchmark variable. Okay, how about intercept? Ano ibig sabihin ng negative 3.39? Okay, dollars yan, di ba? So, and it's even statistically significant. Di ba? 3 stars. So, it means, class, that on the average, okay, on the average, ano, class? On the average, white, male, single employees, okay, who have no education, okay, let me repeat, non-white, female, married employees who don't have any years of education, no experience, no tenure, no number of dependents, receive $3.39 less. Okay? On the average, let me repeat. On the average, employees who are non-white, female, married, with no education, with no experience, with no tenure, and with no dependents, receive $3.38 less, okay, than their counterparts, ceteris paribus. Okay, saan nanggaling yun, class? Remember, yung intercept, ibig sabihin yan, pag intercept, this is the average hourly wage, assuming that all the parameters are equal to 0. Assuming lahat to 0. Kaya that's why I said 0 education, 0 experience, okay, 0 tenure, 0 number of dependents. However, ito, ano to? Anong ibig sabihin pag race white is equal to 0? Eh di ba non-white yun? Kasi dito, si non-white 0, si white yung 1. Right? So that's why we're interpreting this one, negative 3.39, na ano siya? 0 to. Pag 0 yung race white, ibig sabihin non-white siya. Ito, female siya. Ito naman, married siya. So let me repeat. Married, female, non-white employees who do not have education, no experience, no tenure, no number of dependents, receive $3.39 less than their counterparts. Okay? All right. Sige. Pause muna ako, tapos I will entertain questions if you have any. If not, please, paki-chat naman kung clear so far. Lalo na interpretation ng mga factors, ng mga dummy variables natin. Any questions, class? Any clarifications? Okay, thank you for those who have been chatting. Salamat. Yung iba, May questions ba? Kasi kung walang question, ibig sabihin na ang galing-galing ko na mag-explain. Hindi naman yata totoo yun. I'm sure may mga loopholes, may mga kakulangan din sa explain ko. No? So I hope, okay? I hope kung may questions kayo, feel free to ask questions. All right. Thank you. Okay, so thank you so far. Thank you sa so you should be able, class, to interpret, no? Kapag ganyang factor. Next time pag-uusapan natin paano kung ano. Kasi ito non-white na non-white na female. Paano kung non-white na male? Okay, so yung mga ganong questions, no? Yung combinations ng mga to. All right. Now let's take a look at this. What happened to our multiple R squared? 37%. Of course. May question dito, Carlos. Does that mean that the intercept is represented of the opposites? Remember, thank you for that question. Carlo, paki-share yung question mo sa lahat. No? Because that's a very good question. So let's wait for Carlos. Yan. Thank you, Carlos. So sabi ni Carlos, does that mean that the intercept is represented by the opposites? Sabi natin, ang intercept is that value of your dependent variable when all your predictors are zero. So kapag zero to, no? Zero education, zero experience, 0 years of tenure. Zero yung race white. Ano ba ibig sabihin ng race white na zero? Eh di non-white, di ba? Di ba? Kasi nung itong factor to, ano ibig sabihin kapag zero siya? Non-white yun. Ito, gender male. Eh di female yun. Civil status na zero. Eh di married yun. Kaya nga sabi natin, interpretation nito, on the average. Okay? Female, okay, non-white, female, married individuals with no years of education, no years of experience, no years of tenure, no dependents, receive $3.39 less than their counterparts, ceteris paribus. Yan. Okay, did that answer your question, Carlos? Okay, good. Thank you for that question. No? Any other questions? Okay, good. Thank you. Any other questions, class? Don't hesitate to ask. Okay. Let's take a look at this. 0.3704. Kanina 16% lang, di ba? So, ibig sabihin, the addition of these predictors really increased our R squared. So, yung adjusted R squared natin dito, no, 3619. Ibig sabihin nito, what does that mean, class? That 36.19% of the variation of your dependent variable hourly wage can be explained by our model. Okay, so 36.19, kanina 16% lang. Just using education. Now, with the other variables, we were able to increase the explanatory power of our model. This is expected yan, kasi sabi natin, the more you add predictors, the more will be the adjusted R squared, the R squared. Okay, so let's talk about this, yung adjusted R squared na to. Okay, kasi we need to, okay, in order, we need to explain how is this computed, yung adjusted R squared nito. So to compute for the adjusted R squared, okay, una muna si R squared muna. We need three, this is based on your dati elementary stat nyo, di ba? Meron tayong tinatawag, yung sa ANOVA, analysis of variance, meron tayong SST, okay, sum of the squares, sum, natin this is sum of, small letter lang, sum of squares, total, no? And let's write the formula for this. Okay, gawin natin dollar, and then dollar. Okay, sulat natin. Ano ba yung SST? So yung SST natin SST is equal to, okay, sum of the squares of the total, kino-compare natin yung actual values natin with the base model natin. Ang base model natin, we're not going to use the variables. Ano ba yung pinaka-base model? Just get the average of hourly wage. Okay? Kung kunin natin yung average ng hourly wage, then whatever the race is, whatever factors there are, hindi natin gagamitin yan. Basta ang prediction natin, ang magiging hourly wage is still the average. No? So we can i-subtract natin, no? Y sub I is your actual value minus Y mean, no? Okay, and then lagyan natin to ng squares siya, no? Squares. Ibig sabihin, kukunin natin difference tapos square natin. Alright? And then i-add natin, no? So let's sum. Alright, yan, no? Alright, so that's our formula class. The sum of the squares of your total is, kung gusto nyo lagyan ng dito, pwede naman lagyan yan. Yan. Underscore. Oops, mali. Dapat to underscore. Dapat may parenthesis yung curly bracket yung buo. Oops, nawala. Alright. Nawala si min. Okay, so it's y sub I. Sum natin, no? Sum natin si y sub I minus, ima-minus natin lahat ng sa y sub I yung average ni y. Okay? Square natin yung difference na yan, tapos isa-sum up natin. That's your sum of the squares of your total. Okay? And then we have your SSR. You have sum of squares of regression. All right, this time, gamitin natin yung mga yung mga independent variables. All right? So, i-compare natin ngayon yung value na makukuha natin by using the model, by using a linear model. Okay? So, we call it SSR. So, gawin natin, copyin natin to para mas mabilis siguro. Control C, Control V. Okay, so this is SSR. And our SSR will be y hat. Si y hat, ito na yung predicted value natin. Okay, underscore. Okay, y hat, no? Minus y mean. All right. So yun ang equation natin, class, no? Ng SSR. Sum of the squares of your regression. So what happened here was we used the predictors, dependent variables natin. Tapos sinubtract natin sa mean. Okay, we're stating here that by the use of the regression model, na-improve yung natin, yung prediction. Kasi kanina lahat mean lang ang gagamitin natin, di ba? Okay, and then we get the difference and then square it and then sum it. It's called the sum of the squares of your regression. So this is also called your sum of squares explained. No? Explained. That's why others call this, yung iba ang tawag dito SSE. No? Yung iba naman SSR. So just be aware. Kasi yung susunod, din natin to. Okay, sulatan natin to. Copy ko na lang. Control C, Control V. This is now your SSE. Sum of the squares of residuals na to. So this is now residuals. Yung mga error terms natin. And this is now sum of squares unexplained. Okay? And this is your SSE is equal to yung difference ng y natin, y sub I minus yung hat natin. Residuals, ba naalala nyo, class? Residuals, yung difference ng mali ito. Dapat to actual, no? Ay, sorry. Ito pala ito. Tama to, no? Actual minus yung predicted natin. Squared and then sum. All right. So let's compute class, no? Let's compute yung ano natin, yung mga SST, SSR, SSE. And then I'm going to show you how we generate this R squared at saka yung adjusted R squared. All right. So Control Alt I. Let's first compute for your una muna mag-create mo tayo ng object na y sub I. I'll call it, tawagin ko na lang y sub I. These are your actual values. Alt. So si y sub I, kunin natin siya from our wage data. Okay? Our wage data, kunin natin yung column 8. Di ba? Kasi ito yung wage data natin. Ang kailangan lang natin ito. Ito yung ano natin, ito yung actual na values. Ito yung pinipredict natin yung hourly wage. So I'm subsetting it, wage, lahat ng rows, and then 8th column. If I run this, I will now see that si y sub I natin, where's y? Ito y sub I, no? 526 observations. So, yan. May y sub I na tayo. No? Alright, then, ano pang kailangan natin? Kailangan natin si min. So, y min. Okay, so si y min, ilan natin dito? Y min is just equal to, di ba yung ano natin? Mean ng wage, hourly wage. Yan. Average lang siya. So isang value lang yan, no? Isang value lang yung average natin for the whole hourly wage. So let's run this. Okay. Yan, y min, 5.896. All right, last yung y hat natin. Kailangan natin si y hat. Yung predicted values natin. Y hat is, you get it from the model 1, model 2 pala, di ba? Model 2 tayo. $, the fitted values. So yung fitted values, those are your predicted values. Okay? And let's see y hat. Asan na si y hat? Ito. So ito yung mga predicted values. No? So take a look at tinala natin yung yung head ni y hat. First 6 values. Yan. Okay? Ito yung predicted values. So that's our y hat. Okay, let me pause for a while. Questions, class? Paki-chat naman please kung clear so far yung discussion natin. Why are we generating this? Para ma-compute natin si SST, si SSR, at si SSE. Okay, good. Thank you. All right. Okay, so punta na tayo dito sa, create ulit tayo ng ano. Okay, let's now compute for the SST. SST is equal to sum. Okay, ano muna natin ha? Kunin muna natin yung SST, di ba? Y actual value minus average, di ba? Ito yung SST class, total, sum of the squares of the total. Actual value minus the average. Ayan. So, remember sa SST, wala tayong ginagamit na model, yung average lang. And then we square this. Square natin. Now, once na square na natin, gagawin natin, kunin natin yung sum. Oops. I-sum na natin siya. So sum, open parenthesis, close parenthesis. There. Okay? Sum ng yung difference ng actual minus average. Square natin siya. And then get everything, the sum of everything. So the sum of the squares total will be ito. Ito class, 7160. 7160.4. So that's the lagyan natin dito, no? Para mamaya anin natin SST. Tapos about SSR. SSR is yung difference, di ba, ng open parenthesis, difference ng y hat, yung predicted value natin as compared to your average. Supposed to improve, no, on your average. And then square natin. Tapos kunin natin yung sum ulit. Sum ng mga squared deviations ng actual value at saka ng average. So this is your SSR. Sum of the squares of your regression. Preprint natin mamaya. And then lastly, SSE. No? So this is the difference between to ng yung actual natin minus yung predicted value natin. We get the difference, no? But we have to square that. Kasi yung difference nila, 0 lang yan eh. And then get the sum. All right. Okay, and this is called your SSE. Sum of the squares of your errors or sum of the squares unexplained. Ibig sabihin, hindi kinaya ng model natin na i-predict yun. Okay? So, i-run natin itong tatlong to. All right. We now have this. No? This is your SST. This is your SSR. This is your SSE. Okay. Now, what does this tell us? Ito yung total variance natin, yung variability. 2652 of that was explained by the regression model. 4508 was not explained. Unexplained to. Ito yung explained. So now we can now compute for our R squared. Let's call it R2. R squared is equal to, it's just the ratio. No? Yung kaya natin i-explain divided by yung total na variation. Okay, take a look at that. No? SSR, sum of the squares of regression, ito yung variability na na-explain ng model natin. SST, yung total variability. Alright? So, if we run this, Control Enter. Okay. Para ma-print 37.04. Okay. Compare natin to class sa model natin. Take a look. 37.04%. Okay, so we were able to compute for the multiple R squared. Ay, time na pala, no? Guys, may I have just 2 minutes? Tapusin ko lang to, ha? 2 minutes, 3 minutes, ha? Okay, but if you need to go, you may do so. All right. So, and then, meron tayong tinatawag na R squared adjusted. Okay, this one I will have to show the formula. Ang adjusted R squared natin, ito ko isusulat yung formula muna para mas kita natin. Oops. Okay, R squared adjusted. It's equal to 1 minus a certain factor. No? So, from 100%, ima-minus natin 1 minus R squared. Okay? Multiply this with times n minus 1, and then divide this by n minus k minus 1. Okay? All right. So, 1 minus R squared. Alamin natin si R squared, no? n minus 1. N is the number of rows. Okay? And then here, n is also the number of rows. K is the number of predictors. In our case, we have 7 predictors, diba? So what happens is the more you add predictors here, the more this becomes smaller. No? Liliit yung denominator natin. Pag lumiit yung denominator natin, lalaki yung numerator natin. Pag lumaki yung numerator natin, lumiliit yung difference na to. No? Kasi lumalaki tong buong amount na to. So 1 minus this amount, pag lumaki to, liliit yung ano natin. So R squared adjusted class, when you, for example, when you have 100 here. So di ba pag 100 to compared to 5, this will really be very, very, kung 100 to, this will become very, very small, smaller. So numerator, denominator siya, pag smaller to, lalaki yung buong quotient na to. Di ba? Pag lumaki to, 1 minus this one, liliit yung R squared natin, adjusted. All right? So let's solve that. Alt minus. So 1 minus, meron tayong R squared, di ba? We have already R squared. Na-compute natin R squared. And then times. What's N? N is the number of rows ni wage, no? Which is 526. But let's not write that. Gawin natin N row ni wage. Okay? Minus 1. So this is N minus 1. No? N minus 1. And then we divide it by, okay, N ulit, ito yung N natin, Control C, Control D. So this is our N. Sulat ko muna. N ito. Minus, ano yung K natin? Yung K natin is, gamitin natin number of columns. Number of columns ni wage. So this will give us, number of columns ni wage is 8. No? Bawasan natin ng isa. Minus 1. Okay? So this is N number of columns ni wage minus 1. This will give us 7. Check natin po. Control C, Control D. Kung tama, 7 ba yan? Yes, 7. No? Kasi 7 predictors. And then minus 1 po ulit. Minus 1. So everything we close. Close this one. Close this one. So that's your N minus K minus 1. All right, so that's the formula for adjusted R squared. Control Enter. Type natin R2 ADJ para ma-print siya. Okay, here. All right, 36, no? Wala natin pareho. Yung isa 37.04, yung isa 36.19, and if you check class, if you check yung adjusted R squared natin dito, 36.19, exactly the same. Okay? So we were able to show that our model is able to explain 36.19% of the variation of hourly wage. All right, last one. Okay, we'll just compare using ANOVA, analysis of variance. I-compare natin si Model 1 and Model 2. Si Model 1, di ba yung kanina yan, yung single predictor lang, si education lang. Si Model 2 natin, yung marami. And the null hypothesis here is that the restricted model, yung fewer predictors is better than unrestricted. Yung more. So restricted model, yun yung si education lang. Unrestricted, yung 7 yung predictors natin. Kasi ang ano dito, ang gusto natin malaman, kailangan pa pamdagdagan ng predictors. Hindi ba sufficient na education lang? Okay, so let's see the result here. Okay, and then we have this. Okay, this is the result. Si Model 1 natin, hourly wage regress on education. Si Model 2, hourly wage regress on all the predictors natin. Yan. And the null hypothesis here is that Model 1, the restricted model, is better than the unrestricted si Model 2. what's our conclusion? We look at the p-value, significant at 0.001. So we reject the null hypothesis that the restricted model is better than the unrestricted model. Mas maganda yung unrestricted model. So it makes sense to add the other predictors, okay, compared to just using this simple linear regression. All right? So that's what this means. So we were able to prove statistically that mas maganda si model 2. No? Mas maganda si model 2. Now, next meeting, tutuloy natin to kasi hindi pa tayo tapos. No? Kasi meron mga insignificant na predictors dito. What do we do with them? We just don't delete them all. No? We will have to do what we call a stepwise regression when we delete them one at a time. Okay? All right. So thank you so much for your patience. Let me stop recording.